Dear students, yesterday we have seen in the previous video we have seen the working of the NAND gate, right? And you have seen the detail NAND gate also. Today we shall see something about the NOR gate, right? So the NOR gate again it is a universal gate. Now what do you mean by a universal gate? That means that by employing the NOR gate or NAND gate, we can realize all other gates like OR gate, AND gate, NOT gate, and all other gates we can realize. So such gates are called as the universal gates. So out of the different gates, NAND and NOR gates are usually called as the universal gates, right? Now it performs the complement of the OR logic. So you know that OR is usually represented by the output of the OR gate is represented by y is equal to a plus b, right? So the output of the NOR gate, it is complement of this, that is a plus b, that is a plus b bar. The output of the NOR gate, it is the complement of the logic of OR gate, right? So and this is the representation of a NOR gate. So A and B are the inputs, and there is a small circle at the other end at the output side. So y is equal to a plus b bar, that is the output of the NOR gate. Now what about the truth table of the NOR gate? Now as I told you, it is the complement of OR. Suppose if there are two input A and B, so the output will be 1. So because the output of OR gate is 0 plus 0 is 0, its complement is 1, right? So output of the NOR gate is y is equal to a plus b bar. Similarly, when a is 1 and b is 0, it is the output of OR gate is 1, its complement is 0. Similarly, when the inputs are 0 and 1, the output is 1 again, and the output of the NOR gate is 0, complement of 1 bar. Similarly, when the inputs are 1, the output is 1 plus 1 is 1, so and its complement is 0. So this is the output of the NOR gate. You can see here the difference between the output of OR gate and the NOR gate, right? So it is exactly the opposite, 0, 1, 1, 0, 1, 0, 1, 0, right? So and suppose if you consider a detailed NOR gate, so we are making use of two diodes, D1 and D2, right? And we are making use of a transistor Q. This is it is represented as by the transistor is represented by a circle, and there are three terminals, collector, emitter, and base. So this is the base resistance, and these two are the two diodes through which the input is supplied, A and B, right? So this is the collector, and a supply of 5 volt is supplied to the collector, and RC is the collector resistance, and usually the emitter is grounded, right? So and output is connect between collector and emitter always, right? So the output it is y is equal to a plus b bar. Now here up to this point, it is as good as it is nothing but a OR gate, right? So here it performs like a NOT gate, and the total output will be it's the output of a NOR gate, right? So this is the detailed NOR gate. So now what is the working? This working I will send the notes to you. Very simple one. When A is equal to 0, B is equal to 0. So what will be the output? So the diodes are reverse biased, therefore no current flows into the base of the transistor. Therefore the resistor go to the cutoff region and acts like a open switch. Therefore the output is output gives 1. Now this is in the first case when both are 0, 0. When A is 0, B is 1, in this case diode D1 is reverse biased and D2 is forward biased. Therefore sufficient current will flow into the base transistor, which drives the transistor into saturation. Therefore, the output will be 0. And similarly, in when A0 and B1, so diode D1 is forward biased and the diode D2 is reverse biased, and so again there is a saturation region. Therefore, output is Y is equal to 0. When A is equal to 1, B is equal to 1. So in this case, both the diodes are forward biased. Sufficient current flows into the base of the transistor, and the transistor is driven into the saturation, right? Therefore, the output Y is equal to 0. So this is how a NOR gate is working, right? So in the examination, there is all chance of asking detailed NOR or NAND gate, right? So be sure about it, right? Now, in the previous class, I mentioned about solving the different Boolean equations. Now, suppose a Boolean equation is given. In such case, we are supposed to write the schematic diagram for the output of the transistor, output of that particular problem, right? So say if there are so this is the one question which was asked in the previous question paper, right? So I'll have to draw the logic circuit which realize the following Boolean expression. The Boolean expression was given, and accordingly we must write the logic circuit. So let us consider one such problem, right? So the Boolean expression which was given is y is equal to a dot b bar y, that is equal to a dot b bar plus c bar. Now it has to be written in the form of a logic circuit. Now how to write the logic circuit now? So anyway, there are three inputs, A, B and C are the inputs. So the output should satisfy this particular equation. Now how to write that? Now so since B is the input, to get B bar, the input has to be passed through the diode anyway, right? So it is like this. It is passed through a diode. Say if B is the input, the output is B bar. Similarly, if C is the input, C bar is the output coming from the diode, right? Next, it is passed through an OR gate, because you must get B bar plus C bar. So to get B bar plus C bar, you have to pass this output from the diodes has to be passed through a OR gate, so that output will be B bar plus C bar now, right? Now there must be one more input, that is taken as A, and so the output should be A dot B bar plus C bar. So now it has to be passed through a AND gate, like this, right? So the output coming from this will be Y, which is equal to A dot B bar plus C bar, right? So this is how we are representing it. So this is A, and the output from the OR gate is B bar plus C bar. So to get this product A dot B bar plus C bar, so it has to be y is equal to A dot B bar plus C bar. And it is also asked to find out the value of y for A is equal to B is equal to 1 and C is equal to 0. C is equal to 0. Now let us substitute the value. So y, that is equal to A is equal to 1 dot B bar is 1 bar plus C bar is 0 bar, right? So this is 1 dot, so 1 bar is 0 and 0 bar is 1, right? So this is 0 plus 1 is 1, therefore this is equal to 1 dot 1, which is 1. Therefore output y is equal to 1, right? So this is how you have to answer this, right? So similar to this, several other problems may be asked, so you must be able to answer them. Okay, thank you.